it'll ask you if you want to download the application, or it'll ask you if you just want to just view it through Microsoft Teams. You do not have to download the application, because then you might miss out on whatever material is being discussed. So with that being said, we'll go ahead and get started. Dr. Jonathan Watkins is working in the Math Resource Center for now. He will be leaving us. When are you leaving again, Jonathan?
Well, my official last day is August the 3rd.
It's very unfortunate, but we have him for now. So he'll conduct part 1 and part 2 of the workshop. I know that at the end, some people still might have questions, and trust me, that's pretty normal. He will direct you to who can help you moving forward before you take the Praxis test. We have resources in our Math Resource Center in the new BAT building, which is the newer building that was recently built on U of L's campus. So if there's any other resources that you need, please feel free to email me or reach out to Jonathan. I will send a follow-up email after the workshop. I'll be chiming in and out. You might not see me visibly because I'm off today, but I did want to be able to be here to support the workshop. So if you have any questions, let me know. I believe Miss Wanda is still on here. Wanda, are you staying the entire time? Are you muted? She might be.
Yes, I am muted. Yes, I might work on the side, but yes, I intend to stay.
Okay, and if you have any issues, I'll be watching the chat. Please send me a message or just send me an email if you're experiencing any technical difficulties, and I'll be able to help you out. So with that being said, we will now turn it over to Dr. Watkins. Thank you again, Jonathan.
Thanks so much. Good talking to you. Okay, so right now it looks like, Maria, that you have the little button clicked for having your hand raised. Did you have a question?
Yes, there's an error message when I was trying to download the file that Sherry said. I just double click and it didn't allow me to download it. I don't know if anybody else tried it, but I could not do it.
Okay, and you didn't get the email? Did it come through?
No, I did not.
I'll send it to you. I have her email.
Okay.
Thank you. Yeah. Thank you. And thank you for letting me join it.
Absolutely.
Yeah. No problem. Well, I'll have all the slides up on the screen and we'll make sure that you get it. And so it may take a little while for your school filter to let the email through because it's about a 1 megabyte attachment. So I know sometimes there's a little bit of a delay. So, okay. So we'll go ahead and jump in. I'm going to try to share my screen here. And 1 second. Okay, can someone just confirm that they can see the PowerPoint slides okay? All right, good. I'm seeing head nods, so that's good. Okay. So again, I'm Jonathan Watkins. So I work for REACH. And so if you're not real familiar with the University of Louisville, REACH is the academic support unit at U of L. So I've been working with students who need extra help or just want extra help in math. That's kind of been my role at the university for many years. And I coordinate some courses where we work with students who kind of want to brush up on their math. And so so hopefully I'll be able to help you today. I'll do the best I can kind of in this virtual setting. Again, this is the first time for me to kind of lead a virtual version of this workshop. I've done this workshop many times, but usually it's face-to-face. So obviously it's a different experience. Just a little kind of agenda for today, kind of what we're going to be doing. So those are my kiddos. We've been exploring lots of places in nature over the last few weeks and months, especially with a 3-year-old. Got to get him out of the house. And so that's Evan. He's 3. That's Natalie. She's 6. We'll do a few introductions. I'll talk to you a little bit about the exam that you're going to take. Some of you all have already taken it, but I know a lot of you haven't. And so we'll talk a little bit about the exam. Then today we're going to focus on number and quantity problems and data, probability, and statistics problems. So those are the kind of problems we're going to play with today. And then next week we'll look at algebra and geometry questions. I'll give you a little bit of homework if you want some practice to do before we meet next week, and kind of give you a little preview of what next week's going to look like. So again, just a little bit of my background. So I'm the Assistant Director for REACH Math Resources, and I coordinate U of L's Gen 103, 104 program. Those are math courses designed for students who come in and they're considered, I don't like the term not college ready in math, but but they have some areas that they need to work on in math. And so we kind of have these courses to help them. They're very customized for what individual students need. And then hopefully we're preparing them so that they'll be successful their second semester in whatever math course, quantitative reasoning course they need for their program. So that's kind of my jobs at Reach. We have a math tutoring center, which is great, that I work with. And so Reach is a great place on campus. So if you find yourself on our campus taking some classes, those kind of things, keep in mind that Reach is a great resource. So I teach math courses, also teach math education courses. And so I work with future math teachers, and that's actually why I'm leaving. I'm going to become a math education professor in the school, Ball State up in Indiana, in August. And so that's kind of my next plans here. I'm a former university supervisor, so I've kind of been in the schools working with teachers. My background is that I started as a high school math teacher and absolutely loved the experience. And so my degrees are in math, and then my PhD is in math education. So that kind of gives you a little bit of a background of kind of who I am. Normally I ask who you are, but in this kind of setting, it'll be a little bit hard. But Sherry did send some information to me to give me kind of an idea of your backgrounds. And so thank you all for joining us, and hopefully you'll get some good information out of the sessions this week, and hopefully if you can attend next week too. All right, so one kind of interesting thing about the exam that Sherry and I just learned is that there's a new version of this test that you have to take in math. So the only problem is we don't know for sure if you're going to have to take the old version or the new version. And so I'm going to give you a little bit of a background about both. The good news is it's the same topics. The difference is how much of each topic is on the test. So the test, as it has been for many years, and again, it's called the CORE for short, Core Academic Skills for Educators. The old version of the test, they gave you 85 minutes to complete 56 questions. So you had about a minute and a half for each question. All of the questions are either multiple choice, selected response, which means that there may be multiple answers instead of just one, but there's still kind of that multiple choice type format. You can just click more than one answer, and then a few where you actually type in the number answer. You are given an on-screen calculator during the test, but as you can see, it's pretty basic. So just keep in mind that during the test, you'll only have a pretty basic calculator to use. So for those of you all that are used to using a graphing calculator or some type of calculator that's more sophisticated, that's usually not going to be allowed on this test. The breakdown of the old test was 4 different areas. And so as you can kind of see the breakdown, number and quantity was about 30% of the test, probability and statistics about 20%, geometry about 20%, and then algebra was about 30% of the test. And so that was kind of the breakdown of the old test. Again, all of these topics are still in the new test. It's just a little bit of a different breakdown. In particular, there's not as much algebra and geometry on the new version of the test. So if you like algebra and geometry and you have a choice, you might want to take the old test. If you don't want to do as much algebra and geometry, you might want to take the new test if you're given the option. So the new test, and by the way, there's numbers for the test. So if you're kind of wondering, am I taking or am I signing up for the old or the new test? The old test, if you'll notice at the top here, has a number of 5732. 5732. The new test has a number 5733. So that's how you can know if you're taking the old or the new test. So the new version is 90 minutes. So they decided to give you 5 extra minutes. It's still 56 questions. So you still only have about a minute and a half per question, but again, they're giving you 5 extra minutes. Still have multiple choice, selected response, and short answer questions. You still have a basic on-screen calculator, but kind of here's the difference. On the new version of the test, there's now 10 fewer algebra and geometry questions because they actually combine those into one category. And so there's only 18 total questions about algebra and geometry. On the old test, there were almost 18 questions of just algebra. So fewer algebra and geometry, and instead they really beefed up the statistics and probability and kind of data questions. And this isn't real surprising because there's a big push for quantitative reasoning now. And so so that's kind of, I think, the reason why they decided to really ask a lot more questions about data and statistics. And there's also a few more number and quantity questions, and so there's 3 more of those. So just kind of a little bit of a different breakdown of the test. So that's the newer version. So this week, again, we're going to kind of focus on number and quantity and statistics and probability. Next week, we'll look at a lot of algebra and geometry questions. And so that's kind of give you a breakdown of what topics we're going to cover. And I'll have another handout for you next week with some practice problems that we're going to look at in algebra and geometry. All right. So I'll take just a second. I'll switch out of this mode for just a minute to see if anyone has questions. So I see some hands. Now, Sherry, did you have something you wanted to say, or do you just have your hand raised from earlier?
That was from earlier.
I guess Sherry's not around at the moment. Wanda, did you have something you wanted to say?
Yes, Sherry just said that was from earlier. The other thing, I did have something, but it's gone now. But I want people to know that when you raise your hand, you have to click on it again to lower your hand. I don't think they all know that.
Okay. Thanks. Yeah, so click the button once to raise your hand and another time to lower it. I'll also kind of keep an eye on the chat, so let me hop over and see. All right. Wanda, are you kind of keeping an eye on the chat? Because I can't keep both.
I'm working the chat, Jonathan. If I need you, I'll holler.
That would be great, because when I have it on the people side, I can't see the chat and vice versa. So Maria, did you have a question? Okay, yeah, so if you'll just click that hand button, it'll just take your hand back down and you won't have that up anymore. All right, thanks. Okay, so we will hop back in unless there are any other hands or any questions before we get going. All right. We're going to get started. So here's kind of how I set up these sessions, and it usually works pretty well. So what we'll do is I'm going to show you some questions. First, we'll kind of talk about the major topics, and then we're going to go through some questions. Hopefully, you'll be able to see them. If you have some pen and paper handy, that would be great. And I'm going to actually give you, because you have about 1.5 minutes per question on the test, I'm going to give you 1.5 minutes to look at each question, to do your best to answer it, and then we'll talk through it. After I get through several questions, I'll kind of take a break, and then so keep any questions that you have until we get through kind of a few questions, and then we can go back and look at anything that you have questions about. But instead of stopping, because it's so hard to kind of stop and take these breaks, I'll kind of wait until we've done a group of questions, but please keep your questions and let me know if there's anything you want to talk about. Okay, so the first area is number and quantity. So to give you an idea of some of the things that you'll need to be able to do in terms of things in number and quantity would be order of operations. So when I was a kid, I learned please excuse my dear Aunt Sally, PEMDAS. So we'll talk a little bit about order of operations, working with fractions. So it may have been a while since you've had to add, subtract, multiply, or divide fractions. So we'll talk a little bit about that. Operations involving integers. So integers would just be positive and negative numbers. So like the whole numbers, 1, 2, 3, 4, 5, but then also the negative numbers, -1, -2, -3. Also operations, so addition, subtraction, multiplication, division that involve fractions and decimals and percentages. Ratios and proportions, working with percents, in particular, percent increase and decrease. Some number theory, so this is things like finding the factors of a number, looking at charts and graphs and being able to kind of interpret those, looking at the area model, unit conversions, scientific notation, working with powers like, 5 to the 2nd power or 5 squared. Roots would be something like square root of 2. And then estimating amounts. And so those are some of the big topics that are covered in number and quantity. So we'll look at some practice problems that will hit a lot of these topics. But again, those are some of the ideas that are important in number and quantity. All right, so we're going to look at some questions. And so again, I'm going to set a timer for each question for 1.5 minutes. Now, some questions will probably not take you a minute and a half. Some will probably take you more than a minute and a half, and that's okay. When you're taking the actual test, hopefully it will balance out. But I want to give you an idea of what it feels like for each question about how long you should be taking. Because the biggest problem that I've heard from students is that they tend to run out of time sometimes. And so just kind of keep that in mind. So, all right. And again, if you have the handout, you're more than welcome to use the handout that I sent. They'll have the same problems, but we'll get started. So the first question we're going to look at is, what is the least common denominator of the following fractions? 2/3, 3/4, and 5/6. So what is the least common denominator? You'll have a minute and a half. And if you're not muted, this might be a good time to mute yourself. We'll kind of hear a few people in the background. Okay, so that's a minute and a half. Hopefully this problem shouldn't take you quite a minute and a half. This might be a type of problem where you could save some time and use it on some of the other more difficult questions. But it's really important on this question to kind of emphasize the idea of terminology. So you're going to have a lot of terms that you may not have heard for a while. And so in this problem, it's least common denominator. So in this case, you're looking at the denominator, and that's going to be the bottom of the fractions here. And so we have a 3, a 4, and a 6. And to find the least common denominator, you want to find the smallest number that's divisible by all of these, right? And so so we need a number that's going to be divisible by all. So we have like the number 6. Well, 6 is divisible by 3, and 6 is divisible by 6, but it's not divisible by 4. So that won't work, right? We could look at the 12 here, right? Well, 12 is divisible by 3, 4, and 6. And so that will be the least common denominator, which is choice B. Now, 24 is also a common denominator. If you notice, 24 is divisible by 3, 4, and 6. But it's not the smallest one. And again, we're looking for the least common denominator. So this is an important idea when we start working with fractions later, when we're adding and subtracting fractions. And so again, it's very important as we go through this and as you look through some of the study materials for Praxis, that you really pay attention to these terms because they will come up, and I'll kind of point them out as we go along. But again, least common denominator, it's the smallest denominator that will be divisible by all of these denominators, okay? And so that's the least common denominator. Okay, so let's kind of move on. So again, I'll give you lots of test tips along the way. So my first test tip for you is be sure you really pay attention to the terminology because it will come up. And again, these questions that I've created here are really based on, I've taken several versions of the Praxis test myself. Kind of as a study. When I went through these, I kind of marked down a lot of the big ideas, and they're also in the study companion that I'll tell you about later as well. Okay, so on we go. Here's question number 2. So we've got some kindergarten students were asked to give their favorite food. The result for 350 students are shown below. How many more students chose chicken nuggets than pizza? So that's your question. It's out of these 350 students, how many more students chose chicken nuggets than pizza? All right, give you a minute and a half.
Jonathan, you have some hands that are raised. Maybe they've gone down now.
Yeah, I'll probably try to go through just a couple of questions, and then I'll take a break after I get through a couple and see what questions we have. Okay, so that's 1.5 minutes. And so let's take a look at this one. And so this might be one where it would be good for me to try to use the whiteboard. So I'm going to try to jump out and see if I can use the whiteboard. Okay. So you have to bear with me. I'm going to be writing on this whiteboard using a mouse. So if you've ever tried to sign your name using a mouse, you know how interesting it can be. So on this problem, we've got students, 46% want chicken nuggets, 32% want pizza. And so one way that you can tackle this is to say, okay, well, if we have 46% that like chicken nuggets, 32% want pizza, that's 14% more that want chicken nuggets, right? 14% more. And so you might be tempted to pick answer A, but again, the question didn't ask what percentage of students wanted chicken nuggets than pizza, but actually how many students. And so if 14%, and if you'll remember to write 14% as a decimal number, you move the decimal 2 places to the left. And so to write 14% as a decimal, we can write 0.14 or 0.14.
Jonathan.
Yes.
I know I'm going to drive you crazy. There are people screen. I can see the screen. I don't know why they can't.
Okay, some people cannot see the screen?
Correct. We've got at least 3, 4 maybe.
Okay, yeah, so sorry, for some of you, depending on what device you're on, you may not be able to see. I'll talk through everything that I'm doing, and so if you can't see the screen, we'll just kind of do the best we can. But again, if you have 14% more that want chicken nuggets than pizza, we can write 14% as 0.14 or 0.14, and then we can multiply that by the total number of students. So in this case, we have 350 students. So if you want to find out what is 14% of the total number of students, we write 0.14 times the total number of students, which is 350. And then when you do that, you should get 49 students. Now, from teaching these workshops, I know some students have kind of taken a different approach. They've actually figured out how many students like chicken nuggets. So it's 46%. So you can follow this same idea. You can do.
Hey, Jonathan.
Yes.
I think people can't see the whiteboard. A lot of people are saying they can't see it.
Okay, so let's see.
I don't know.
To think of what a better option would be. Maybe I can just share my screen and pull it up, do the best I can. Hang on one second.
And it's not everybody. It's only like, so I see Jessica Stevens says she can see it. I can see it, but there's a lot of people who said that they can't.
All right, let me try doing something a little different.
Sorry, I didn't mean to cut you off.
No, you're okay. Let's see if I can do this. So we're going to think on the fly here a little bit. So I'm going to hop back over to my desktop. Let me see what happens. So I'm sharing my desktop. Let me see if I can pull up like Paint or something like that and just do it that way.
Perfect.
So I think most people are able to see my desktop. So
yeah, while you're doing that, what I'm seeing is people who logged in as a guest cannot see it. So, and there's a lot of people that logged in as a guest.
Okay.
So yeah, hopefully this will work.
So what about this? If I write like this, can you all see what I'm doing?
Yes, they're
Okay, it
saying
looks like
yes.
everybody can see.
Okay.
Yes,
So I'll do my best to write in paint here, and we'll go with it. Okay. So 14% of 350 is 49. So that's one way that you can figure out the answer there. The other one is to actually figure out how many students want chicken nuggets, how many students want pizza, and so you can follow the same thing, right? So we know 46% of the students, so 0.46, 46% of the total, 350, like chicken nuggets. We know that 32%, so 0.32, 32% of the total like pizza. And so we can actually figure out how many students like chicken nuggets. I got 161. Then if you take 32% of 350 by doing 0.32 times 350, you end up with 112 students. And then that gives you, when you subtract those, then you find out that there are 49 more students who want chicken nuggets rather than the pizza. All right, so sorry, my writing is going to look like my 6-year-old or my 3-year-old, but we'll try to do it this way whenever I write. Okay. So let's look at one more, and then we'll stop and take. I'll take some questions if you have them for these first 3 problems. So the next one is, what is the distance between -2/3 and 3/4 on the number line? What is the distance between -2/3 and 3/4 on the number line? All right, give you a minute and a half. All right, so that's a minute and a half, so I'll hop back out to my paint here for a minute. See if I can get a new one. All right. So if we're looking at a number line here, pretend like that's a straight line. So if this is 0, so we've got -2/3 down here. So again, to the left of 0, we have the negative numbers. To the right, we have positive. And then we're looking at 3/4. So it'll be up here somewhere. Now, when you look at this problem at first, you might be tempted to just try to add these 2 fractions together, -2/3 and 3/4. But you can't do that in this case because they want you to find the distance between them. And distances are always positive. So like if I ask you how far is it from -2/3 to 0, that distance will be 2/3. Right? So the negative is telling us kind of we're going this direction, right? But the distance between here and here is 2/3 if we were to measure it with a ruler, right? And then the distance between here and here will be 3/4. So really what this problem is asking you to do is to add the fraction 2/3 and 3/4. All right. Now, in order to add or subtract fractions, we have to have a common denominator. So if you remember back at problem number 1, we kind of learned a way to find that least common denominator. It's going to be the smallest number that is divisible by 3 and the smallest number that's also divisible by 4. So if you think about, so we can't use 4 because it's not divisible by 3, but you could think of kind of skip counting through maybe, or we could say, okay, with 3, we've got, 3, 6, if we're doing multiples here, 9, 12, 15, you could think about kind of multiples. Then for 4, you have 4, 8, 12, 16, and so on. And so you can see the smallest that they have in common will be 12. So that's going to be our least common denominator, 12. So if we have 2/3, we want to add 3/4, and we need a common denominator. What I can do is I can multiply the top and the bottom, the numerator and denominator of the fraction, by whatever will give me this least common denominator. So since the denominator is 3 here, I need a 4. So I also need a 4 here, because 4 divided by 4 is 1. So that's what makes that a legal operation. Here, I need to multiply this 4 by 3, so I have to also do it in the numerator, because again, it would cancel back out to 1. All right, so now I have 2 times 4 is 8. 3 times 4 is 12, so now I have 8/12. And then with the second one here, I have 3 times 3 is 9. 4 times 3 is 12. And once you have a common denominator, now you can actually add the numerator. So 8 plus 9 is 17. And then when you add and subtract fractions, you don't actually add or subtract the denominators, it stays the same. So 8/12 plus 9/12 equals 17/12, which was choice D. All right, so I'm going to pop back out here for just a minute and stop sharing my screen so that I can see you all, and give you just a second if you have any questions about the first 3 problems we've taken a look at. Any questions or comments? Brenda, I see your hands up. And you're muted, so just remember that if you want to speak, you will have to unmute yourself. So Brenda, did you have anything you wanted to say? Anybody else?
Maria wants to know if they're going to have paper to be able to work the problems when they're at the Praxis. Do you know?
That is a good question. You may have to look at, I'm going to show you after we get done today, the companion little handout that the ETS, the people that make the test, actually have. And so that should tell you everything. That's something I don't know off the top of my head. I'm pretty sure that you can use paper, and I would think that they would provide it for you, but I don't want to give you misinformation. I'm sure you can write down things. Does somebody that's taking it know whether or not, I'm seeing some head shakes. Does somebody want to say something?
You've got some hands raised too.
All right.
I was going to say they give you a 4-sheet booklet at the testing site.
Thank you so much. Yeah.
Nanette has her hand raised, I think.
Yeah,
Yes, they didn't give me a booklet, but they gave me loose pieces of paper, and if I needed more, I could just raise my hand. They would take the old paper and bring the new back.
Great. Thank you so much. Anyone else? Any questions or comments so far? All right, so we'll hop back in and I'll take another break after a few more questions and see if you all have anything for me. Okay. Again, make sure you're going to find and one reason why sometimes students struggle with these kind of tests, the questions are written a little differently than the way that you would see them in school. And so instead, again, like on this problem, instead of just asking you to add 2/3 and 3/4, they added that extra difficulty of actually having to kind of interpret the situation and what's going on. And it might be tempting, again, just to add those two numbers and then you'll get the wrong answer. And of course, they'll always put those tempting wrong answers as answer choices. So if you did -2/3 plus 3/4, you will get one of the answer choices there. So take extra time to make sure you really understand the problem and what they're asking, because the wording can be different for sure. Okay, so next problem. This one usually takes people a little bit more than 1.5 minutes, so I'll still set the timer for 1.5 minutes, but I may give you a few extra seconds on it. All right, 2 buses arrived at Grand Central Station at 11:30 a.m. The first bus at the station arrives every 45 minutes. The second bus arrives at the station every 20 minutes. So what's the next time that both of the buses will arrive at the station at the same time? So it's 11:30 a.m. Both of these buses are there. So now, when will be the next time that these 2 buses will be there at the same time? All right, give you a little bit of time. So that's 1.5 minutes. I'll give you a little bit longer. This is one that would probably take a little bit longer. Okay. So in this problem, we know that it's 11:30 a.m. when we're starting. So that's kind of 0.0. This problem is going to use that idea of kind of the idea of least common denominator, but we can also call that the least common multiple. So if we kind of do multiples of a number, when's the first time that they're going to share the same number? So at 11:30, we'll have that kind of be time equals 0. So the first bus will arrive every 45 minutes. So after 11:30, it'll arrive 45 minutes later, 90 minutes, 135, 180, 225, and so on. Now, if you think about the other one, I was getting tired here. It's going to arrive every 20 minutes, 0, 20, 40, 60, 80. So if you keep going, eventually you'll hit 180. And so that's going to be the first time that these numbers are going to match. So that's what we call the least common multiple. It's just like that idea of least common denominator. This is the smallest number that they have in common when you're looking at the multiples of 45 and the multiples of 20. Okay, so that's the first time they meet. So 180 minutes, that would be 3 hours later. And so if they're there at 11:30, 3 hours later, 12:30, 1:30, 2:30. So 2:30 p.m. would be the next time that they're going to be there at the same time. So again, we're just kind of skip counting by 45, skip counting by 20 to find the least common multiple. That would be the first time then that they'll both be there again at the same time. All right. So on this one, my test tip for you is definitely pace yourself. This is a question that takes a little bit longer. So if you read a problem and you think that it may take you a while or you don't really understand what it's saying, I recommend that you skip the problem. It is pretty easy at the end of the test to figure out which problems you haven't answered yet and go back and answer those. So don't feel like that you have to answer every question in the order that you get it, right? You can actually skip a problem. If you think it's going to take too long or you don't know how to do it, skip it and then come back to it at the end so you don't spend too much time because, again, you only have that minute and a half per question. Okay, the next one usually gives people fits, and so we'll spend a little bit of time talking about this one. But which of the following problems can be solved using the area model below? So if you look at the picture, you have kind of that shaded region. So think about how much that is and how much the individual boxes are there. And we'll talk about this in a minute. So which one of the following problems here can be solved using this area model? Okay, so these are the kind of problems that have elementary school parents pulling their hair out because this is the kind of math that we teach in elementary school, helping students understand adding, subtracting, multiplying, and dividing fractions. And so let's kind of take a look at what's going on here. Let me hop back over. So in this problem, let me see if I can use my little shapes here. Hey, there we go. We have a shape that's kind of divided into regions. Okay, so pretend, use your imagination that those are the pretty squares that we have in the problem. Okay, and so they shade in this part, this part, this part, and this part. So if we're looking at that and we say, okay, how much of the whole rectangle is shaded? That would be 2/3. Okay. Now, let me backpedal for just a little bit here. So let me do something kind of different on the side. Let's say that we have the problem 8 divided by 3, or 8 divided by 2. So 8 divided by 2 we know is 4. But what exactly does 8 divided by 2 equals 4 mean? It means that if you have 8 things, and you can divide them into groups of 2, then you'll have 4 groups of 2, right? So 8 divided by 2 equals 4 because you're basically saying how many groups of 2 are in 8. So how many groups of 2 are in 8? There are 4 groups of 2 and 8. So I'm doing that because now we're going to look at this thing. So over here we have 2/3 shaded. And then how big are these little squares? Each of the squares is 1/6 of the total. So just like we can say how many groups of 2 are in 8, 4, we can do the same thing here. Each of these squares is 1/6. So we can divide it by 1/6, and that's basically asking this question. How many 1/6, so this is 1/6 here. I could even change colors. So this is 1/6. So how many 1/6 are in 2/3? Well, there are 1, 2, 3, 4. So there are 4 1/6 in 2/3. So it's the same idea as we had over here with whole numbers. It's just a little bit harder to think about it in terms of fractions, but it's the same idea. How many groups of 2 are in 8? 4. How many 1/6 are in 2/3? There are 4 of them. And so that's why 2/3 divided by 1/6 is equal to 4. If you don't believe me, we can actually just compute 2/3 divided by 1/6. So if you need a little refresher on dividing fractions, the way you divide fractions is you change the division to multiplication, and you take the reciprocal, or you flip the second fraction. So 1/6 becomes 6/1. So 2/3 times 6. So you multiply the numerators. When you're multiplying fractions, you multiply the numerators. 2 times 6 is 12. And then you multiply the denominators. 3 times 1 is 3. 12 divided by 3, hey, you get 4. So 2/3 divided by 1/6 is the same as 2/3 times 6/1. Then you multiply straight across. 2 times 6 is 12. 3 times 1 is 3. 12 divided by 3 is 4. So that's how you kind of do the area interpretation of dividing fractions. And if it's still a little bit confusing, you're not alone. This is usually one of the hardest problems when I go through that students really struggle with that idea. So hang in there. Okay. So I'm going to tackle one more question, and then any of these 3 that you want to look at, we can do that. So the next one that I want to look at is using the table that I give you there, determine how many cups are in 3.5 gallons. How many cups are in 3.5 gallons? And again, after this question, we'll take a little break to do a little Q&A. So this is another problem that tends to take just a little bit longer, so feel free to keep working just a little bit longer. Okay, so there's several ways that you can tackle this. For those of you all that are used to kind of converting with units in this kind of setting of maybe making a recipe or something, it may not be that hard for you to kind of keep up with it in your head about whether you need to multiply or divide. For those that want a kind of a systematic way to do this, you can actually do a little process that will allow you to cancel these units so you end up with what you need at the end. And I'll kind of show you what I mean. So if you want to convert from one set of units to another, so in this case, cup or gallons to cups, you start with whatever you have. So in this case, we're given 3.5 gallons. And then you're going to multiply it by some type of unit conversion here. So in this case, we know that 4 quarts equals 1 gallon. Now we want to get rid of gallons because we're trying to get out of gallons and into cups. So to get gallons to cancel out, we put gallons down here in the denominator, and then we'll put quarts in the numerator. And so we know that 4 quarts equals 1 gallon. And now we can cancel out our gallons. So now we've just converted gallons to quarts. But we don't want quarts. So next we can use the fact that there are 2 pints in a quart to get rid of quarts. So we have quarts in the numerator. To get it to cancel out, we'll put it in the denominator. And then we'll have pints up here in the numerator. So 2 pints equals 1 quart. And now we can cancel our quarts because we have quarts in the numerator and denominator. So now if we did 3.5 times 4 times 2, we would have how many pints are in 3.5 gallons. But again, that's not what we want either. So we keep going, and we know that there's a half a pint in every cup. So again, we need to put pints in the denominator because we want to cancel it. So you have to have 1 in the numerator, 1 in the denominator, cups in the numerator. So we know that 1 cup is equal to a half or 0.5 pints. Pints will cancel. So we've canceled gallons, quarts, pints. We finally ended up with cups, which is what we want. So now to determine how many cups are in that 3.5 gallons, we just compute 3.5 times 4 times 2 and then divide it by 0.5. And when I did that, I ended up with 56 cups. So again, you don't have to do it this way, but this is just a little trick that you can use. It's called dimensional analysis. It sounds really scary, but all it is the idea of when you want to cancel out a unit, you just need 1 in the numerator and 1 in the denominator to cancel it out. So that's how you know to put 4 quarts over 1 gallon instead of putting 1 gallon over 4 quarts. It's like, how do you know which one goes in the top or which one goes in the bottom? You always want to put it in the opposite place of the other one so that they will cancel out. So we have gallons in the top here, so we need gallons in the bottom here. We have quarts in the top here, so we need quarts in the bottom here so that they'll cancel out. And then you just keep going until you end up with the unit that you want at the end. So 56 cups. All right, so I'm going to stop there. We've done 3 more questions and see if anybody would like to ask some questions. I'm seeing some hands raised. So let me pop over. So I see Vanessa, do you want to unmute yourself and ask a question?
Yes, on the previous problem.
Yes.
On the area, why could I not just count and multiply the 2 by 2?
So
let me. One.
So let me go back to using my whiteboard here. Okay, so have something like this, right?
Right.
Okay, so we're kind of had this shaded.
Right.
Okay, so now tell me your question again.
I wonder why can't we just do 2 times 2, the area formula, just of the shaded area, and still arrive at 4?
I mean, it depends. So there's this could represent lots of different things. Just given the choices that you had on that question,
Right.
is the reason why like that would be the only thing that would kind of make sense out of the answer choices that you had. Right. And so in that specific case, like I said, the other options were like, 2/3 times 1/6. Well, that would be, 1/6 of 2/3. Well, that's not kind of what we have here, right? So if you have the case, like I said, in this one, one of the options, that we ended up choosing was this. It's just thinking about, how many of these are in these, and that's kind of what it's showing here. So just out of the options that we're giving, that's the only one that we could really, I guess, make sense out of the ones that we're given. If you were just given this area model and asked to come up with, some type of math problem that you could solve using it, you could come up with other things.
Okay, thank
Does
you.
that help? Okay, yeah.
So are you saying that the answer to that question was B?
So the answer is B, yes.
Okay, thank you.
Yeah. Because it ends up, because what it's showing you is it's showing you little groups of 1/6 here. Let me pick a different color. So each of these squares is 1/6 in size. So again, what this math problem here means is how many 1/6 are in 2/3. And so here's 2/3, and each of these are 1/6. So there are 4 1/6 and 2/3. So yeah, that's the best one there. Great. Somebody else, I think, was it Nanette that had your hand raised? And again, remember when you're,
It was
sorry,
a
go ahead.
leftover hand raise. Sorry. I had it left over from the last
Okay,
time.
yeah. So if you'll just remember to kind of unclick it. Alicia, yes, sure. You just unmute yourself there.
Okay, sorry. For the last one that we just did,
Yes.
the 3.5 times 4 times 2 times 1 over, I guess, can you show me that last piece where we have the 1/2, like how we got that? Yeah.
Yeah. Okay. So yeah, and this is always, like I said, I mean, I know we're throwing out a lot of different ideas here. And so once we got here, right, the 2 pints equals 1 quart.
Mm-hmm.
So once we got there, we had canceled the gallons out, we had canceled the quarts out. So we were in pints, right?
Yeah.
So then the last unit conversion that I gave you on the problem itself, and they'll give you those, they won't expect you to know them, was that 1 cup equals 1/2 a pint. So to decide which one goes where, you just look at where pints. So pints is in the numerator or in the top. So that means that it has to be in the denominator, the opposite place.
No, I got that. I guess, can you show me how
how to actually compute
calculate it? Yeah, compute it, please.
So the way I would compute this is I would start with a 3.5. So everything in the numerator, 3.5 times 4 times 2. So that'll give you 28 in the numerator.
Mm-hmm.
So you have 28 in the top divided by 0.5. Now it depends on what calculator. Are you using like a calculator where you could use a decimal number? Because then you could just do 28 divided by 0.5 if your calculator will let you do that.
Okay.
So if you do 28 divided by 0.5 or 0.5, you should get 56 then.
Okay. That's where I was losing it. So thank you.
Yeah, and I changed it to 0.5 because you have to be careful. Sometimes, like if you try to do 28 divided by 1/2, you just have to be careful because 1/2 usually with basic calculators is like 1 divided by 2, and your calculator may do something, give you something that you don't want. And so the easiest thing to do is if you could take a fraction and write it as a decimal number, that's usually easier to work with in the calculator.
Okay. All right. Thank you.
Yeah. Sorry, I didn't understand your question at first there, but yeah. Okay. Any other questions? Again, I'm not watching the chat as much. Wanda, are you still kind of monitoring the chat?
Yes.
Okay, thanks. All right, so again, Vanessa and Brenda, your hands are shown as raised. So if you can just click that hand button again, it'll disappear and I'll quit calling on you. Okay.
Question.
Brenda has a question?
Yes.
All right, tell me.
It's the number 3. I had 1/12 because it was a negative number and a positive number. And I always thought a negative and a positive would make whatever the larger was. So I came up with 1/12. But you're saying
Yeah,
that
so-
it's actually, you're adding two together, even though it was a negative number.
Yeah, so if the problem had been negative, I think it was at negative 2/3 and 3/4.
Yep,
So yeah,
and the
so
3/4 was positive.
so if you were needed to just add those two numbers, then yes, you would have gotten something different, right? So the reason why you didn't keep it negative in this problem is it was asking you about distance. So
Okay.
anytime you hear the word, sorry, I'm trying to write the word distance. So anytime you see the word distance, that's going to tell you that you have to use just positive numbers because you can't really have negative distances.
Okay.
And so if you'll remember, I don't know, sure a lot of you have heard the term like absolute value. So basically I didn't use it when we worked the problem, but whenever you're dealing with distances, you're taking the absolute value of those numbers. So really what we're doing in this problem is the absolute value of negative 2/3 plus the absolute value of 3/4, because absolute value is like distance from zero. So negative 2/3 is 2/3 away from zero. 3/4 is 3/4 away from zero. And that's why we added just the positive numbers. So I don't want you to get the misunderstanding that if you see a problem and it says negative 2/3 plus 3/4 to automatically change it to be positive. We only did that in this problem because we were dealing with like distances.
Okay. That makes
But
sense.
if the problem had just said, what is the sum of negative 2/3 and 3/4, you would have done it the way that you had worked it.
Okay. All right.
Does that help?
Yes. Yes.
Good. Okay. Good. Great. All right. Other questions? Vanessa, did you have a question?
I don't.
Sorry, you're muted now. I can't hear you.
Okay, wait a minute.
Now I can hear you.
Okay. Okay, I don't know why it keeps going up because I keep hitting it and it doesn't stay down.
No problem. Okay.
I double click. Is it off now?
It went off. Try one more time.
Yeah.
Because it went down and now it's down.
And every time I see.
Oh, okay. It's okay. Did you have a question?
No, I guess you're going to have to ignore me because you won't know if I have a question or not.
No worries.
Okay.
Yeah, so feel free to unmute yourself and just ask if you have a question. That's not a problem.
Okay, thank you.
Okay, so we'll hop back in. We've got 3 more of these, and then we'll switch over to probability and statistics. So if you're wondering, if you don't have the handout there in front of you, we've got 3 more to go. I'll take some questions, and then we'll hop over and do a few problems related to statistics and probability. Okay. So let me share again. All right. So the next problem is one family's water consumption in thousands of gallons over several months is shown in the bar graph below. What is the % increase in water consumption from June to August? All right, so I'll give you a minute and a half. % increase of water consumption from June to August. Right. So this one's a little hard to do if you don't know the % increase and decrease formula. And so there are going to be a few formulas that they are going to expect you to know, and I'm going to give you a list of those next time. But one of them is dealing with percent increase and percent decrease. And so I'm going to give you my version of the formula because I think it's pretty easy to remember. Whenever you're wanting to calculate percent increase or decrease, so if you hear the words percent increase or decrease in a problem, it's new minus the old divided by the old, and then to turn it into a percentage, you multiply by 100. So new minus the old over the old times 100. It's the new amount minus the old amount divided by the old amount times 100. If you end up with a positive number, then that's a percent increase. If you end up with a negative number, then that's going to be a percent decrease. So in this case, our new amount is 5 because we had 5,000 gallons of water. Or we used 5,000 gallons of water in August. In June, I only used 3,000 gallons of water. So the new amount is 5, the old amount is 3, the old amount is 3. And because we're wanting to know the percent increase from where we started, and so that's why we divide by the old number here. So if you divided by 5, that's the problem, is you want to know the percent increase from where you started. And so we started at 3,000, now we use 5. All right, so 5 minus 3 is 2, so 2/3 times 100. So 2/3 is just 0.6666 repeated. If you multiply that by 100, you get 66 point, and then just repeating sixes, so you could round that to 7. And so it's going to be a 66.7% increase. So the new amount's 5 minus the old amount 3 divided by the old amount 3 times 100. So 2/3 times 100, which is again going to give you 66.7 when we round. So that's the percent increase. So this formula, again, I'll give you a list of formulas next week, but that's an important one to know because they will expect you to know it. Okay, and that's my tip for number 5. There are several formulas you're expected to know for the test, and so again, be sure you kind of commit those to memory before you get started. All right, question number 8. Which of the following numbers are greater than 3? Which of the following numbers are greater than 3? Now, in this case, I made it a multiple choice question, but actually, this would be one that would be more like a selected response where you would click all of the numbers that are greater than 3. So I'll give you a minute and a half. Okay, so which of the following numbers are greater than 3? When I look at this, square root of 2 and square root of 3, you may not know because those are going to be, decimal numbers. But when I get to square root of 9, again, remember with square roots, the question being asked is, what number multiplied by itself will give you the number here, right? And so in this case, square root of 9 is equal to 3 because 3 times 3 is 9. So I know that square root of 9 is 3, so that's not greater than 3. And so if square root of 9 is equal to 3, then it's probably safe to assume that the square root of a smaller number is also going to be less than 3. So I'm going to kind of rule those out. Now, if the square root of 9 is exactly 3, then if I go larger, square root of 10, then that should be larger than 3. And if you take the square root of 10, you'll see that it's about 3.16. So square root of 10 is greater than 3. And then pi, if you'll remember, is approximately 3.14. So that's also greater than 3. So it looks like these last two options, 4 and 5, are going to be the ones that are greater than 3. So that would be choice D here. All right. And then the last number and quantity problem that we're going to look at for now. First, a test tip. Be sure you read all of the answer choices before you select an answer. Again, you don't want to just pick, square root of 10 and then forget to check all of them. And so be sure, especially on those questions that have more than one right answer. But even on all the other ones, you want to look at all the answer choices to make sure that you're not picking, maybe the answer is 10 and you accidentally pick -10. And so maybe when you saw that 10 and -10 are there, that you could double check and make sure that your sign is correct. Okay, so the last number and quantity question we're going to look at for now, the ratio of female to male students in a class is 7:2. So if there are 12 males in the class, what is the total enrollment? So the ratio of female to male students in a class is 7:2. If there are 12 males in the class, what is the total enrollment? Okay. So I'm going to hop out on this one and use the whiteboard. Okay, so on this problem, we're dealing with ratios and proportions. So we know the ratio is 7:2. So you can write that as like this. You could also write it as a fraction, 7:2. And so we know that 7 is the number of female students and 2 is male. Now, in order to keep the ratios equivalent, so we have 7 to 2. So, if we doubled it, 14 females, then that means that we would have 4 males. You could keep going 21 and 6. So as you increase by 7 females, you have to increase by 2 males each time. Okay, so you could actually do this until we got to 12 males, or you could kind of figure out what the scale factor is. So again, if we're looking at 7 to 2 and we know there's 12 males, then our scale factor to get from 2 to 12 is 6. So if we multiply 2 by 6, we get to 12. And you could do the same thing here then. You could multiply the 7 by 6 and you'll get 42 females. So you could use the idea of scale factor. You could continue to do these equivalent ratios. So, 21, the next one would be 28 and 8, then we have 35 and 10, and then we would make it to 42 and 12. So equivalent ratios, you can kind of look at the scale factor here and figure out what it will be. You can actually set up algebraically, there's lots of different ways you can tackle it. So there are 42 females. Now be careful, if you chose 42, you fell into the trap because the question didn't ask how many females were in the class. It asked for the total enrollment. So you have to watch out on the test. They love to do that. They love to have you find something, but then that's not what they asked for in the question. So if you picked 42, you did all the math right, but you forgot to get the total enrollment, which is adding 42 and 12, which is 54. So they love to do that to you. So just kind of be aware that that could happen. So yeah, read the question very carefully. Be sure you answer the question that's being asked. Okay, so that's the last number and quantity question I have. So I'll stop sharing for a minute so I can see if there are some questions. So any questions about those last three or any of the questions related to number and quantity? Vanessa's always the good student with her hand raised.
Well, I'm trying to get it off because I did make that mistake and not read through, and so came up with 42, but it was short.
So
right.
So just kind of watch for that because, like I said, I don't know why they like to do that, but they like to ask you something, make you do an extra step to actually get to the answer. Okay, so we're going to jump over.
Jonathan?
Yes.
I walked away for a minute and there's a question in here that says, what is the answer to the last one?
So real quickly, actually, why don't I just, to make sure everybody has the answers when they go back and kind of look at the things, I'll go through all of them real quickly for you. So for number 1, I have B, 12. So B as in boy, 12. Number 2, I have C for cat, 49. Number 3, I have D for dog, 17 over 12. Number 4, I have B as in boy, 2:30 p.m. 5, I have B as in boy, 2/3 divided by 1/6. 6, I have E as in Edward, 56 cups. 7, D as in dog, 66.7%. 8, D as in dog, choice 4 and 5. Number 9, D as in dog, 54 students. All right. Any other questions or concerns before we switch over to statistics and probability? All right, so I'm looking at our time. We're at about 12:20, so we've got about 40 minutes left. So what I may do this time, there are 8 questions. So I'm thinking that I'm going to go through the first 4 questions. Then we'll take a pause, and then I'll do 4 more questions. So again, save any questions that you have so that we don't have to stop between each one, and I'll kind of do 4 and 4. So we hopefully get through all of the questions before 1 o'clock. Okay. So statistics and probability. So what are some of the kind of things they may ask you here? They'll ask you about statistical questions and understanding what they are, and we'll talk about that in just a minute. What a random sample is, kind of some of those standard things that you've learned before, the mean, the median, the mode, the range, weighted averages, looking at data, so looking at graphs, diagrams, scatter plots, lots of different things. So we'll look at a bunch of different graphs today. Finding the probability of simple events, so I'll remind you how to find probability, and talking about whether events are independent or dependent of each other. And so we'll look at an example of both of those. Okay, so we'll hop right into the first question. A laundry basket contains some brown and black socks. In particular, there are 12 brown socks in the basket. So if the probability of drawing a black sock out of the basket is 1/4, how many black socks are in the basket? All right. And just a reminder to mute yourself. There are a few people I think that are not muted right now. Okay, so this one can be challenging. One tip I have here is if you get stuck on a problem, remember that you are going to have on most of the questions some answer choices to look at. So you could actually try some of the answer choices and see which one seems to work. So let me pull up the whiteboard here. Okay, so in this one, we know that we have 12 brown socks, and we don't know how many black socks we have. And we're not sure how many total socks we have. But we do know that the probability that we're going to get a brown sock is 3/4. Now, there are only brown and black socks in this problem. And so if the probability of getting a brown sock is 3/4, then the probability of getting a black sock must be 1/4, because all of the probabilities have to add to be 1 or 100%. So there's 75% chance you're going to get a brown sock. So there's going to be a 25% chance we get a black sock. Now, there's lots of ways to tackle this. Again, on this problem, I might just try some different ones to see what would happen. So, you could try, for instance, the first answer choice is 3. Well, if you put a 3 here for black, that would be 15 total. So what would be the probability then of a black sock? Well, there are 3 black socks, 15 total socks. So 3 divided by 15 is 1/5. So we're close, but we're not at 1/4. We're at 1/5. So it can't be 3. So we can erase 3. Then I think the next answer choice was 4. So you could try 4 black socks. For some reason, it's not going back. Let's see, there's brush. So if we try 4 black socks now, if we have 12 brown, which we're given, 4 black, that would be 16 total socks. So 4 black socks divided by 16 total socks, 4 divided by 16, hey, that does give us 1/4. And we can even check, is 12 divided by 16, does that give us 3/4? And if you divide both of those by 4, you'll see that you do get 3/4. So 4 is the correct answer on that one. You want 4 black socks. So again, there's other ways to tackle this, but that's probably the most straightforward way, is to actually work through from your answers there. Oops, sorry about that. Okay, so on we go. Which of the following is not a statistical question? Which of the following is not a statistical question? Give you a minute and a half. Okay, so you may be wondering, well, how do I know what a statistical question is? So here's usually the answer that I give when people ask me, how do you know if a question is a statistical question or not? And that is there going to be variability in the answer? So what do I mean by that? I mean, if I ask you the question and I ask somebody else the question and said, you know, I want you to explore this question and then come back to me with an answer. If the two of you would come back with exactly the same answer, then it's not a statistical question. If it has an exact answer that you can go and find and come back and report, that's not a statistical question. But if the two of you go out and do an investigation and come back with different answers, slightly different depending on what method you use, that would be a statistical question. So let's kind of like look down through these. So A says, how many hours per week do college students do homework? So again, if I asked a couple of people this question, they did an experiment and came back, we would probably get different answers. Maybe one person asked mainly freshmen and sophomores and somebody else asked juniors and seniors. Well, maybe the juniors and seniors are doing more work than or actually on this question, it's not homework, it's just work, right? But again, some students may work more than others. Maybe one person asked more non-traditional students, somebody asked traditional students, and so they got different answers. So there will be some variability there. B, do female students spend more time on homework than male students? Again, it's going to depend on, you know, your sample, who you're asking, you know, those type of questions. So there would be variability there. Do elementary school teachers work more hours per year than high school teachers? Again, this is a question that if I ask several people to go out and conduct an experiment and come back, you would end up with different answers. They may be similar, but they wouldn't be exactly the same. So that would be a statistical question. On average, how many years do teachers remain in the profession? Again, this may vary depending on states. You know, some states that are more teacher friendly may retain teachers more than other states that are not as teacher friendly. So there could be, you know, differences there. E, how many teachers in Kentucky have tenure? Well, it may be hard to calculate, But you could go and actually to each school district in Kentucky, ask them how many teachers have tenure and come back. And if you both did a good job, you should end up having the same answer. And so how many teachers in Kentucky have tenure is not a statistical question because it's not one that has variability. There is an exact number of teachers that have tenure in Kentucky. And while it may be difficult to find out that number, it does exist. And you can maybe even call like the State Educational Professional Standards Board, and they probably have a record of it. And so, so that is a question that has an exact answer. And so therefore it's not a statistical question. Statistical questions have variability, and depending on who you sample, how you set up your your survey or whatever, you're going to end up with slightly different answers, or maybe not slightly different answers. They could be majorly different answers. Okay, let's keep going. So this problem says the table below shows the number of children in 50 randomly selected families in the U.S. What is the average number of children per family in this sample? So in the first column, we have the number of children. So with these 50 people, no one had more than 6 children. They all have between 0 and 6 children. And so the way you read the table here is, there were 8 families that had 0 children. There were 12 families that had 1 child. There were 21 families that had 2 children, and so on. Okay, so that's kind of how you read that chart. I'll give you a minute and a half to see what you can come up with. Okay, so this one takes a little bit longer. I'm going to go ahead and set it up on my whiteboard, but feel free to keep working if you're not quite there yet. This is what we call a weighted average problem. Okay, so on this problem, let me tell you what you don't want to do. What you don't want to do is say, okay, so you either have 0, 1, 2, 3, 4, 5, or 6 children. So I'm just going to add those numbers up, and there's 7 different ages there. 7 different number of children, 0, 1, 2, 3, 4, 5, 6. So if you add those and then divide by 7, you'll get 3. So if you did it that way, the problem is you're not taking into consideration that some families have more children and fewer children than others. They're not all uniformly distributed. And so what we have to do in this case is actually do a weighted average. So the way I've kind of written this out here is we have 8 families that have 0 children. So you can do 8 times 0. We have 12 families that have 1 child. So we're going to multiply 12 and 1 together. We have 21 families that have 2 children. So that's going to be 21 times 2. And then you just keep going until you get all the way up to you have 1 family with 6 children. And then we can do 8 times 0 is 0, 1 times 12 is 12, 2 times 21 is 42, and you just keep going. 6 times 1 is 6. And when I calculated this, I ended up with 86 children in all. So if you consider how many total children that all of these 50 families have, it's 86. And when you get this, now you need to divide that by, so there are 50 families in this situation. So 86, then divide that by 50, and you'll end up with approximately 1.72. So 1.72 children per family. So this is a weighted average. Okay, so we're going to look at one more of these and then I'll take some more questions. So again, any of these that you have questions about, just hold them for one more question and then we'll get going again with some more Q&A. All right, last problem before we take a little break. If 2 cards are drawn from a standard deck of cards, what is the probability that both cards will be spades? Now, if you don't know a whole lot about cards, here's what you need to know. There are 52 cards in a standard deck of playing cards, and 1/4 of them, or 13 of them, are spades. So there are 13 spades out of the 52 total cards. Okay, I'll give you a minute and a half. Okay. So on this one, I'll kind of show you the test tip before we jump in. If you're trying to find the probability of 2 different events, so in this case, the probability that you get a spade and then you get another spade, the way that you calculate probabilities is you take the probability of the first thing and you multiply it by the probability of the second thing, given that the first thing has already happened. And so I'll kind of explain what that means now. So in this case, we want to know what's the probability that we get a spade. Let's see how well I can draw a spade here. And then you want to get a second spade, right? So what's the probability of a spade? And then you want a second one, the probability of the second spade. That one doesn't look as good. All right. So what's the probability that we get our first spade? That's going to be 13 spades out of a total of 52. So to find the probability of something happening, the numerator is how many ways that can happen. The denominator is the total number of ways. So there are 13 spades in the deck. There are 52 cards in the entire deck. So 13 out of 52. Now, what's the probability that we're going to get another spade? Now, you cannot just do 13 over 52 again, because we're assuming that we got a spade already. The first card is a spade. So what's the probability that the first card is a spade? 13 out of 52. Okay, so you've got one. So now what's the probability that this second card is a spade? Well, how many spades are left? If we drew one spade out already, there are now going to be 12 spades left. And then how many total cards are left? Well, we just took out one, and so there's still 51 cards in the deck. So this would be an example of what we call a dependent event, because the second event depends on the first event. And so the first event was drawing a card out and getting a spade. The probability of that happening is 13 out of 52. The second event then is drawing another spade. Now we only have a 12 out of 51 probability of getting a second spade because one spade is already out of the deck. So when you multiply fractions, you just multiply straight across. So you get 156 divided by 2652. And you keep simplifying down. You can keep breaking this down. And you should end up getting 3 over 51, which is choice B as in boy. Now that can actually be simplified. This was a mistake on my part, to 1/17. And so really choice B should say 1 over 17. Now, if you get kind of hung up in all of these little fractions here, another thing is to remember that 13 out of 52, you could go ahead and simplify that to 1/4 before you even get started. So because 13 out of 52 is going to be 1/4, then you have 12 over 51. And you can also simplify here. So you have a 12 in the numerator, a 4 in the denominator. You can simplify. So that's going to be 3 over 1. And now when you multiply straight across, you end up with 3 over 51. And again, that can be simplified to 1/17. So the answer to that one is choice B, 3 over 51. But again, it's a typo on my part. It really should be simplified even further to 1 over 17. Okay, so I'm going to stop there. That's 4 questions, and I'll let you all ask any questions that you have about those.
That 13, you got it because of the proportion that you got there of 1/4 of the, I mean, I'm not a player. I mean, I suppose that somebody who knows their cards, they will know that there's 13 of each.
Yeah, so
but I got it out of the proportion of 1/4 of the cards are spades.
Yes.
Okay.
And so if you know there's 52 total cards, so what you could do if you want to find out how many or how to get this 13 is that you can say, okay, if there's 52 total cards, and I know that 1/4 of them are going to be spades, and I can do 52 times 1/4, and that's how you can get the 13.
Perfect.
Yeah, because 1/4 of 52 then will be 13. Good question. Other questions?
Going back to number 27, the slide 27.
Oh, okay. Hang on 1 second. I'll go right there. This one?
Yes.
Okay.
Yes, right there. Number of children 5, but number of families 0. I was wondering how you still, because the question was.
So it would end up
selected families.
Yeah, so it'll end up working out kind of the way that this, so you have 8 families that have 0 children. So when you multiply those together, you get 0,
right.
And then, 12 times 1. So when you get here, you can just multiply those to get 0. And that won't really affect, again, in the end, you just want to know the total number of children that all of these families have. So since there's 8 families that have 0 children, that doesn't give us any new children. Same way here, we have 0 families with 5 children. So when you multiply those together, that still gives us 0 more children. And so that's when we're trying to find our total number of children. If you can either kind of ignore those two and just, say 12 plus 42. The only thing is when you divide at the end, you don't want to ignore that there were 8 families with 0 children. So you still want to divide by 50. You don't want to divide by like 42 because that doesn't take into consideration that there are people that don't have any children.
Okay, because that's what I did. I just ignored it and I didn't. Okay, so thank you.
So yeah, you just don't want to ignore it whenever you divide. You still want to divide by 50 because if not, it's going to, like if you ignore this 8 families with 0 children, what's going to happen is it's going to look like people have more children than they do. But the people that don't have any children, we want that to kind of be a part of it too, because that is important to know. It brings down the average number of children that we have.
Gotcha.
Okay. Other questions? All right. Thanks for hanging in there. I know this has been a little weird trying to kind of hop around. I like this view where I can kind of see a lot of people. I don't know, when I share my screen, then I'll lose everybody. So for the sake of time, we're just going to have to talk together through the last 4 problems. I think you've got an idea, though, about how long you're going to have on average per question. So hopefully that's helped a little bit. But we'll just go ahead and talk through these last 4 so that I have time to also tell you a little bit about some of the resources that are available to you. So, and I apologize on this next problem. It's my bad. I accidentally gave you the test tip on your handout instead of the actual graph. So it would help if you actually have this graph. So this is called a dot plot. And the question says, the top dot plot below shows the number of hours of sleep reported by 14 people on a given night. What is the mean and the median number of hours respectively? So if you remember, when you calculate the mean or the average, you're just going to add up all of your data points and divide by the total number of data points. So here, this dot plot is showing us that one person got 5 hours of sleep. There were 4 people that got 6 hours of sleep, 2 people that got 7 hours of sleep, and so on. So to calculate the mean, you would literally just say, okay, 5 plus, and then you would add 6 4 times for all 4 people there. You would add 7 twice. You would add 8 plus 8 plus 8 plus 8 plus 2 9s and a 10. And so when you add all of those data points, 5 plus 6 and so on, all the way up to 10, you'll end up with 103. So that's the total number of hours that people slept, 103. And there were 14 people. So you would do 103 divided by 14. And that would give you about 7.4 hours. So that automatically eliminates choice D and E because they have the mean listed as 7 hours and 8 hours. So that's not right. So it has to be either choice A, B, or C because those are the 3 that have a mean listed of 7.4. Now the median is the middle number. So hopefully you can see my mouse cursor here. So if we want to find the middle number, there are 14 people in all. And so half of that, so if you think about like dividing it in half, the halfway point would be right between person 7 and person 8 because we have an even number. So there's not actually a middle person. There's kind of a middle 2, right? The 7th and the 8th person. So if we count, we have 1, 2, 3, 4, 5, 6, 7. So the 7th person got 7 hours of sleep. If we go the other direction, 1, 2, 3, 4, 5, 6, 7, the 7th person landed at 8. So the median is between 7 and 8. So if we average those, we'll get 7.5. And so that's going to be the median. So the correct answer here is choice B as in boy. 7.4 hours for the mean. And again, we just added all the data points up and divided by 14. Median is 7.5 because the middle 2 people are right here and right here, 7 and 8. So the middle would be 7.5. So it's choice B. Questions on that one? Okay. So again, we'll go through a few of them, but it is important that you're familiar with a lot of different types of representations of data, different graphs and plots. So here's another one. This one's called a scatter plot. It says, which of the following statements best describes the association of the variables in the scatter plot? So if you look at it, this is one of those problems where you kind of think about drawing in like a line of best fit. So if you notice over time, as we increase here, so here's the x-axis, as we increase on the x-axis, this is our y-axis, it's actually going down. So as we move from left to right, we have a line that's going downhill. So if you have a line that's going downhill from left to right, that's going to be a negative correlation. If it's moving up, it's going to be positive. Now, linear means a line. So we kind of have this trend where it's going down from left to right, and it's kind of in a line. And so the correct answer here would be C, negative linear correlation. The positive linear correlation would be if the dots were kind of moving this direction. As we increase from left to right, the dots would be moving upward. Non-linear would mean maybe it's a different shape. Maybe it's like a U shape instead of a line, or just a bunch of random dots. Strong correlation means the dots are going to be really close together. Like here, you can see the dots are really spread out. But if we drew in the line of best fit, if all of the little dots were really close to the line, that would be a strong correlation. And then no correlation would just be a bunch of random dots everywhere. Okay, so I've included in your handout just some little graphs of scatter plots to give you an idea of some of the different correlations. So again, this one shows a strong negative correlation because it's moving downhill from left to right. And also you can see on this one that the points are a little bit closer together than on the problem that I gave you here. You can see the lines are pretty good compared to like here where they're more spread out. Here again, they're also pretty tight. Like you can kind of draw the line in pretty easily here. And this one's a positive correlation because we're moving up from left to right. This one's a weaker correlation because again, you can see the data points are, like if we draw in the line of best fit, the data points are more scattered. And then here they're kind of scattered everywhere. So you could either say like a non-linear or no correlation here. And so the closer the R value, the correlation is to 1 or -1, the stronger the correlation. And if it's closer to 0, that means there's not much of a correlation. And correlation just means there's a relationship. It's associated with each other. All right. Next, in a certain game, players must roll 2 6-sided dice at the beginning of each turn. At any given time, what's the probability that a player will roll a sum of 8? So what you have to do on a problem like this is think about how many different ways can I roll 2 dice? And how many ways can I roll a sum of 8? And so if you think about there's 6, so there's a couple ways you could look at this. So real quickly, there are 6 sides to a 6-sided die. So if you have 2 of them, that's going to give you 36 ways that you can roll 2 dice. So if you're playing a game of Monopoly or something that requires 2 dice, there are 36 different dice rolls that could happen. And then so how many ways could we end up getting a sum of 8? So we have die number 1 and die number 2. Well, we could end up with, how about if we have a 1 here on die 1? Well, the highest, the second one could be a 6. That will only get us to 7. So we'll have to start with 2. So if the first die has a 2 on it, the other one would need to have a 6. If the first die rolls a 3, the second one would need to be a 5. They could both be 4. The first one could be 5 and the second one could be 3. Or the first one could be 6 and the second one could be 2. So there are 1, 2, 3, 4, 5 different ways that I can roll an 8. A 2 and a 6, 3 and a 5, 4 and a 4, 5 and a 3, or 6 and a 2. And there are 36 total ways that you can roll 2 dice. And so that would end up giving you 5 out of 36. That's the probability that you're going to roll an 8. And by the way, for those of you all, if you've ever gone to a casino and you wonder why when you play craps, you lose when you roll a 7, it's because 7 is the most likely rolled number. You have a higher probability of rolling a 7 than anything else. So that's why you lose when you roll a 7, or at least in the second phase of craps. So you get that for free. Okay. So hopping back in this case, I used an organized list to help me count all the different ways that I could roll a sum of 8. There are 5 ways. There are 36 total ways. So the answer to this one is D as in dog, 536. Here's a chart if you want to just kind of see it a different way. So let's say you have these 2 dice. Again, you can see there's all of the different 36 different combinations that you could roll. And then you can see here is a sum of 8, sum of 8, sum of 8, sum of 8, sum of 8. So along this diagonal here, there's 1, 2, 3, 4, 5 different ways out of the 36 total ways that you could roll that. All right, the last problem. We're doing pretty good here. We're going to end right on time. Certain company has both part-time and full-time employees, but only full-time employees receive health benefits. The company's CEO is interested in surveying a group of employees to determine their level of satisfaction with the current insurance carrier. Which method would most likely produce a sample that is representative of the population and be practical to implement? So we're looking for a random sample here. Whenever it says a sample that is representative, it wants to have a group of people that are a good representation of the entire group, which would be kind of a random sample. So the first thing is A, supervisors select several employees in their area to be surveyed. Well, the problem here is the supervisor is going to pick certain employees. They'll probably pick the employees that are easy to work with, right? And so if you let the supervisors decide who's going to take this survey, you're probably not going to get very accurate picture of what's going on with the health benefits. So that's not a good one. You don't want to let people pick who gets to do the survey. B, a random sample of all employees is selected. This sounds like a good choice. The problem here, though, is if we survey all employees, we're going to be surveying a lot of people that don't have health insurance. So if they don't have health insurance, it's kind of hard for them to talk about how satisfied they are with the insurance carrier. They'll probably say they're very unsatisfied because they don't have insurance, right? And so a random sample of all employees, probably not the best way to go. C, all employees are surveyed. Again, probably not real practical to survey everyone, and everyone at this company doesn't have health benefits, so that doesn't really make sense either. D, surveys are mailed to all full-time employees and return surveys are used as a sample. This sounds like a pretty good idea, and we do this a lot of times. We mail out surveys and people send them back. The problem is there's only a certain kind of person who is willing to fill out a survey and mail it back. You're not going to have a very random sample. You're going to have the people that are motivated to take the time to fill that thing out, get it back into the mail, put a stamp on it if you didn't put a stamp on it. You're not going to have a representative sample. You're only going to have a sample of the people that are usually the ones that are always willing to do what you say. And so that's not really going to give you a good idea of like what everybody thinks. So the best solution here is choice E, and that is to assign all of your full-time people a number and then randomly draw numbers and say, if we draw you, we need you to complete this survey. And so that's a way to ensure that you're picking, a random group of people from all of the people that have insurance. So that would be kind of one way that you could produce a representative sample. So that would be choice E. Okay, so before I go into a couple of housekeeping things to kind of wrap things up, any discussion on those last four problems? Thanks for hanging in there. I know this has been 2 hours of math problems, probably more math than you ever wanted to do at one time in your life. But questions about any of those?
I just have a quick comment. I don't know how tricky the Praxis is, but I just saw in social media a graph that it was intentionally the y-axis, instead of having the numbers decrease as they were going down, they moved the axis and the numbers were increasing, but it seemed like the slope was negative, like the COVID numbers of cases were getting smaller. But if you look at the numbers on the axis, you were going from 5 to 10 to 50, and then here the months were progressing. So I don't know if Praxis is tricky or not, but take a look at the numbers if they're decreasing or increasing, because even if the slope looks going down, if the numbers are increasing, is not a negative. It's a positive correlation.
No, that's a great point. Yeah, and actually, a lot of people love to lie with statistics, and the way they do it a lot of times. So watch for this if you're looking at the newspaper or watching the news or on social media. They'll also like expand and make it look like you're talking about the y-axis. If you move the data points really far apart, like every 1% is like this huge bar, you can make it look like it's a huge increase when maybe it's a really small increase. Or maybe they won't give you the whole y-axis, they'll just give you part of the y-axis, so it'll look like it's a really small change. But if you had the whole actual, a nice little drawn to scale y-axis, the line would look different. So you really do have to look at how they scale the y-axis. They love to kind of distort things. And so that's a good point. Hope, I haven't heard from you. Question?
Yes, so I have two questions actually. First, can we go ahead and run through the answers for 1 through 8 in the probability section?
Yes.
And then my second question is, I know that this is being recorded. How will that be available to us later?
We'll have either Wanda or Sherry will send you a way to access it when we're done. So they'll be in touch with you. Okay?
Yes.
And then,
Go ahead.
sorry, I just realized I had another question after that. Instead of just having it all together, could you also make it separate to where we can just look at the PowerPoint itself?
Yeah, and actually what I can do is I can send the actual PowerPoint itself, so that right now you have, like a PDF version of just, the problems, but yeah. I can send the actual PowerPoint presentation to them, and they can then share that with you.
Okay, perfect. Thank you.
Yeah, no problem. So the answers to the statistics and probability questions: number 1, B as in boy, the answer was 4. Number 2, it was E as in Edward. How many teachers in Kentucky have tenure? 3 was A as in apple, 1.72. 4, B as in boy, 3 over 51, which again should be 1 over 17 if you simplify it. Number 5 is B as in boy, 7.4 hours and 7.5 hours. Number 6 is C as in Charlie, negative linear correlation. 7 is D as in dog, 5 over 36. And then 8 was E as in Edward for that last one. Okay, so last thing before we go, and sorry, I know we're just a minute or two over. I'll be real quick. Just wanted to share this with you. On the ETS website, that ETS is the group that makes the Praxis. They have some great resources. So just to let you know, if you Google Praxis Case Math, or you could also Google Praxis Core Math, it'll take you to these materials. If you want the direct link, you have it there. It's ets.org. And then test 5732 will take you to the old test. 5733, if you use that on the end, it'll take you to the new version of the test. So hopefully you'll be able to find out soon which version you'll be taking. Again, the same types of problems, just different proportion of problems. And so there's also something that's called the Praxis Study Companion. And so let me just show you real quickly. So if you pull up the ETS website, this is what you'll see. One, Khan Academy has some free test prep stuff that you can do. So just to let you know, if you're familiar from helping your kids or somebody with Khan Academy, or you may have used it yourself, they have some Praxis stuff that you can access through this ETS website. There's also something called the Study Companion. So this is a study guide. So it has all kinds of practice problems, study tips, all kinds of good stuff. It's 44 pages long. You don't have to read it all, but it's got a lot of good stuff in here, including a bunch of practice problems. And so just know that that's available. And then at the bottom, if you want to pay, I don't necessarily recommend you do it, but you can actually take a full practice test. It's like $20. So if you click at the very bottom, core academic skill for educators, for $20, you can actually do a practice test in the system. The only nice thing about it is, I mean, these are the people that actually created the test. And so, they're going to be pretty close to what you'll see, although I think you'll find that the problems that I've given you are going to be fairly close to what you're going to see as well. So just know that that's available through the ETS website. Just Google Practice Core Math, or you can type in this information directly. And then also, again, I work for REACH, which is the tutoring center at U of L. So just know that we are available. So even if we don't have face-to-face tutoring in the fall, you can access our online tutoring services. It's reach.louisville.edu/tutoring. And you can visit us in the new Belknap Academic Building on the main campus of U of L. So our math tutoring center is in room 241. So we can help you either face-to-face when we do return to campus, or we can help you in our virtual tutoring session. And we do those tutoring sessions through Microsoft Teams. So just like I'm holding this session right now, that's how we do our tutoring. And then just know that next Friday, same time, same place. I'm going to look at some algebra and geometry questions. So if you'd like to review those, please join us next week, or we'll record that session also. And then just know that there's a bunch of additional practice problems in here. So I'll get those answers out to you so that you can, if you want to practice some more number and quantity and statistics and probability questions, you've got some more practice problems there that you can take a look at. Okay, thank you all so much. I'll hang around for a few more minutes for any other questions that you have, but otherwise, hopefully I'll see you in a week.
Okay, Jonathan.
Thank you,
Yes.
Jonathan. I just want to add something really quick before y'all start asking questions. Just keep in mind that the link is different for next week's meeting, and you should have it. If you receive the link for this one, then it's the second link that I sent. The writing workshop, you won't get that until July, because I know people might forget about it because it's like about 3 weeks away. So I'll send that at a later date, but just keep in mind, if you don't have the link, email me directly and I'll get it sent to you. If you have any other questions, please let me know in the meantime, and I will, if Jonathan sends me the PowerPoint, I'll forward all that out.
Okay.
And thank you all so much for coming. Really appreciate it. And feel free to email me. I'll add my email address, or Sherry, feel free to share that out. You're more than welcome to email me if you have some questions as well.
Okay.
I'll be here through the summer, through July. I'll still have my email open for a while, but again, you're more than welcome in the next, couple of months if you have some questions, especially over any of the materials that I've talked about. I'd be happy to talk to you, and we could even set up a Teams call just one-on-one if you wanted to meet with me through Teams. So just, you're more than welcome to touch base with me, okay?
Jonathan,
Thank
it's
you.
Wanda. Somebody asked if you were going to include the worksheets with the PowerPoint that you're sending out. I realize we're saving this. I just didn't know if that would be hard for you to do or not.
So they should already have the worksheet with the questions themselves. That was the PDF that Sherry sent out. So she should already have that part. It'll just be the, like I said, I'll give you the PowerPoint as well.
Okay.
I didn't receive any of the handouts, so how do I get them?
Just touch base with Sherry, and I think she can get that to you one way or another. She should be able to email it to you.
Yeah,
Is that
I
okay,
had it
Sherry?
sent. Wanda sent it out. Yeah, that's fine. There's probably been some issues with email. So one of the mistakes I made when the RSVP was created, human error, I did not ask for emails until I didn't realize that until later. But we have sent it out to every MAT student, every Louisville teacher residency student, and anyone who's emailed me asking for links directly. You should have received it, and it's also in the group chat. But if you did not receive it, just email me. It's Sherry, SHERRY.Durham, DURHAM @Louisville.edu, and then I'll get it to you.
Okay.
If you can't, some people can't download it. I don't know why, but some people can't download it in this group chat. And so if you can't download it from the group chat when I send it, I'll definitely send it to you directly. I do apologize for that.
Okay, thank you.
And you're more than welcome to email me too.
The reason why you can't download is if you signed up as guests, you have to be logged in to do things like that.
Okay.
So is that the issue, that you just need to log in when you get onto Teams?
Yeah, so when you get onto Teams, you want to log in with your Louisville email address, so that you'll have access to everything.
Okay. And if you don't have a Louisville.edu address, it's okay. I'll just still get it sent to you. Thank you again, Jonathan.
Oh, you're more than welcome. And any other questions, like I said, I'll hang out for a few more minutes if there's any other questions, but if not, hope to see you next week. And like I said, we'll get the PowerPoint out to you, and feel free to email me and we can set up a Teams meeting. And I'm on Teams a lot. So you can also, if you type in Jonathan Watkins, you can look me up in Teams, and I'm on here a lot because I'm working remotely still. So feel free to touch base. And I much rather do this than some of the other work that I have to do. So I'd love to talk to you if you have questions. All right. Any other questions or concerns? I'll hop over to see if there was anything else in there. Okay. And Sherry Sherry's email is in the chat. I'll go ahead and type in mine in the chat as well. So that way you'll have it. I'll put it in the PowerPoint as well, but it's J as in Jonathan, D as in David, WATK. So kind of the standard username kind of setup. So JDWATK01 @Louisville.edu. And so I'll put that in the chat there. And you're more than welcome to email me if you have any questions or concerns, or if you need me to send you the PDF, I'm happy to forward you the PDF. Maria, did it ever come through to you that I sent it to your Jefferson email? Good. Okay. Great.
And Jonathan, just assuming it's Wanda, that someone absolutely was lost on one of the problems, which
Oh, I lost you, Wanda.
years, but they could contact you and you could help work them through that, correct?
Absolutely.
Can you say that
pace.
again, Wanda? I didn't even hear
Okay,
that.
I
Sorry.
just said if there were parts of it that you just did not get, Jonathan would be happy to work with you on that particular problem, because a lot of this was over my head because I haven't looked at math in years. Okay, so sometimes you need him to slow down or to ask the questions that you understand, like why did you do this, when he just assumed you knew. But Jonathan likes people. He's a people person and he's happy to help. That's his job, actually, isn't it?
Yep,
Is
it
to help
is.
people.
Yeah, and it
Yeah.
is a little bit harder, obviously, doing it this way because I can't see your facial expressions whenever I'm working through the problems. Or, you know, normally when we do face to face, I always tell people like, stop me anytime you're confused, and I'll address it right then. So this is not ideal, but hopefully it's helped a little bit. And like I said, just let me know. Like I said, if you want to look at some more of the problems, or even some of those additional problems that we didn't get to today, if you want to try to work through those, or if you have any questions about the additional problems, I'm happy to talk to you about those as well.
Thank you.
All right. Well, hey, thanks so much. And I guess we'll hopefully see most of you all next week. And I guess if there's no other questions, I'll log out of here. Sherry, Wanda, do you have anything else for me?
No, I don't. Thank you so much.
And I do not either.
Wanda, great to hear from you. Haven't talked to you for quite a while. So
I know. It's good to see you. I'll see you next week, Jonathan.
Sounds great. Thank you all. Shelley, I see Alicia.
Thank you.
Thanks so much. Have a good night or good
You
afternoon.
too.
And Sherry, I'll talk to you soon. Oh, she jumped off of there. Okay. See you all.